Hello students, now let us look into this problem. Using mathematical induction, prove that sum of cubes of first n natural numbers equals to n square into n plus 1 whole square by 4. So now let us see how do we prove this using mathematical induction. Now let's go into the solution. Now what is the first step? Replace n equal to 1. Show that s of n is true for n equals to 1. So s of 1 is 1 cube is nothing but 1. Now what is s of 1 according to the formula? 1 square 1 plus 1 whole square by 4, which is nothing but 2 square by 4, which is also equal to 1. Therefore, the following formula s of n is true for n equals to 1. So this is step 1. We have proved that s of n is true for n equal to 1. Now what is step 2? We have to assume that for some k which belongs to n, that means where k is a natural number, s of k is a true statement. That means we are replacing n with k and we are assuming that s of k is true. So s of k is nothing but k square k plus 1 whole square by 4. This is a true statement where k belongs to n. Now what is step 3? Now this is the important step. We have to prove that the given formula is true for the next consequent number of k, which is nothing but k plus 1. So we have to prove that s of n is true for n equals to k plus 1. Now let us see how to prove this. Let us replace n with k plus 1 in the formula. So what is s of k? It is the sum of cubes of first n natural numbers or first k natural numbers. Okay, so what is s of k plus 1? S of k plus 1 is sum of cubes of first k plus 1 natural numbers. Now, according to our assumption, we have to replace this sum of cubes of first k natural numbers as k square k plus 1 whole square by 4 plus k plus 1 whole cube. So now what do we get? We can take k plus 1 whole square as common and we get here as k square plus 4 times k plus 1 by 4. This is nothing but k plus 1 whole square k square plus 4k plus 4 by 4. So this is nothing but, as we can see, this is nothing but k plus 2 whole square, right? If we expand k plus 2 whole square, we get k square plus 4k plus 4. So now this formula is nothing but k plus 1 whole square times k plus 2 whole square by 4. So now this can be written as k plus 1 whole square times k plus 1 plus 1 whole square by 4. So now we got the same formula, right? For s of k plus 1, when we have tried to add the first k plus 1 cubes of first k plus 1 natural numbers, we have arrived to this formula, which means s of n is true for n equal to k plus 1. Therefore, the sum of cubes of first n natural numbers s of n so on up to n is nothing but n square times n plus 1 whole square by 4. Therefore, we could prove this using mathematical induction. Hence, s of n equals n plus 1 whole square by 4, where n belongs to natural numbers.